To inscribe an equilateral triangle means to draw it or construct it inside a circle such that each vertex of the triangle coincides with the circumference of the circle. In other words, the equilateral triangle fits perfectly into the circle. So the way we do this is we need our compass and our straight edge, and assuming we've already got a circle drawn here, we need to find the center of the circle, and this is the point at which I stabbed in my compass needle, and this is the radius. So the first thing is to have the radius of my compass set to the same radius as the circle in which I'm going to inscribe the equilateral triangle. So that is the important first step. Okay, so I need to make sure it's exactly there. Now I'm going to think of the circle for a moment as an analog clock, and I'm going to say that 12 o'clock is up at the top, as it would be on a clock that you would see maybe on the wall of your classroom. I'm going to stab the point of the needle of the compass in at 12 o'clock, and with the same radius I'm going to swing an arc just enough so that it crosses the circumference here. I'm going to twist or turn the compass with the same radius over to the other side, and I'm going to swing another arc, and so it's as if I've got a little mark at what would be 2 o'clock and over here at what would be 10 o'clock, and I have this point of the compass that's stabbed a hole right at noon at 12 o'clock. Now I'm going to pick up the needle of the compass and stab it in at my 2 o'clock arc, and without changing the radius I'm going to come down here and make a little arc that crosses the circumference at what would be 4 o'clock. Now if I want, I can go back up and I can make an arc that falls at 12 o'clock. And it's pretty amazing because the point that I stabbed in right here is exactly where the pen crosses. It's not a coincidence. This is a unique feature of a hexagon or an equilateral circle inscribed in equilateral triangle inscribed in a circle. Alright, continuing on, I'm going to pick up my point of my compass, stab it in at the last mark I made, which is down here at 4 o'clock, and come swing an arc at what would be 6 o'clock. And then I'm going to pick up the compass, stab the needle in at that last mark, 6 o'clock, and swing one more little arc that crosses at what would be 8 o'clock. And at this point I can close up my pen, set aside my compass, because I've got these 6 equally distributed little marks that cross the circumference of the circle all around. So it's these points of intersection that I am now interested in, and you may even be able to see that I've got hidden in the code of these marks, I've got a hexagon, a 6-sided figure, as well as an equilateral triangle. Now if I connect every third mark, I'll get the equilateral triangle. So if I start up here at 12 o'clock and I set my straight edge to every other mark, so I start at 12 o'clock, and if I'm moving around the circle this way, I'm going to ignore 10 o'clock and go down to 8 o'clock and connect them with a smooth segment. And then I am here at 8 o'clock. I ignore 6 o'clock and go over here to 4 o'clock and connect them with a smooth segment, and then I do the last one up here, 12 o'clock and 4 o'clock, connect with a smooth segment. I have inscribed an equilateral triangle in my circle. Now it doesn't necessarily line up with the graph paper, which is okay. And there may be some human error here. There's always human error unless you do this in Geometry Sketchpad. But if I want to verify, again, I can always use my compass as calipers to verify. Let's go see if this is in fact an equilateral triangle. If I open the pen and the needle point out to the width of one side, well, that should agree with the other two sides as well, if in fact this is an equilateral triangle. So let me come down here, and we have agreement there, that's congruent, and come over here, we have agreement here, not perfect agreement here, so then I would say there's a bit of human error here, and it's a little bit right there, I think you can see, but I can go back and redo this and see if I can get it with less error. But at any rate, here we have inscribed an equilateral triangle in a circle.